Oh, you thought he was done? No, he's not done. He's back because he's just like, thank you so much for making it this far. Dragon's got feelings. And he also shakes the camera when he flies by. Okay, so sorry. Couple things. First off, I was thinking about it. This box window, this is really called an area model, and that's like the technical term. So y'all should probably know that. We should start calling it the area model. All right. So that's the first thing, and then the second thing that's really important is okay. We're finishing up our algorithm. We did 1 times 7, 7. 1 times 2, 2. 1 times 1, 1. And then we have to do second line, ones place, 0. So second line, ones place, 0. Second line, ones place, 0. Right? On the second line, in the ones place, before you start anything else, you have to put a 0. If you don't put a 0 there, it's going to be wrong. All right, so the next thing that we're going to do is we are going to multiply our 3 tens times our 1 7. So that is 3 times 7. 3 times 7, once again a math fact, equals 21. So what we're going to do is we're going to put the 1 from 21 in the tens place, and then we're going to carry the 2 up on top of the tens place. All right, so we did 3 tens times 7 ones, put the 1 in the ones place, or 1 in the tens place. The reason why, remember, basically we did 30 times 7, which is 210, so the 1 is in the tens place, and the 2 is going to be part of the hundreds. All right, so 3 times 7, 21, put the 1 down, carry the 2. Next up, what we're going to do is the 3 in the tens place times the 2 in the tens place. All right, so what we're looking at is 3 times 2. 3 times 2 is 6. And then we're going to add that 2 from up there. So what we really get is 8. All right, so what we did is we did 3 times 2 equals 6, 7, 8 with those extra 2 on top. So we're going to get 8. All right, finally, I'm going to take our 3 tens and we're going to multiply it by 100. All right, what that looks like though is 3 times 1. 3 times 1 is 3. And just like that, we have our second line. So 1 times 7, 7. 1 times 2, 2. 1 times 1, 1. Then we did our second line, ones place, 0. 3 times 7 was 21, carried the 2. 3 times 2 is 6, plus 2 is 8. 3 times 1 is 3. All right, now, if you'll realize, once again, we have a situation that we can see. All right here, 3 times 7 was 21, right? 3 times 7 was actually 30 times 7. There's your 21. It was 210, right? Because the 0 in the ones place, if you put a 0 right there, that's 210. Once again, you don't have to do the big math because all you have to do with them is a math fact whenever you use the algorithm. All right, the next thing that we did is we did 3 times 2, and that was 6, plus the 2 we got 8, right? 3 times 2 was 6, all right? So that's where we got that original 6. And then finally, you did the 3 times 1, wherever I put that color. There we go. 3 times 1. So once again, there's the 3,000. Okay? So, the only thing that we're missing on is we don't see that 8. All right. So, what we're going to do is we're going to go ahead and add these up now on both sides. 7 plus 0, 7. 2 plus 1 is 3. 8 plus 1 is 9. 3 plus nothing is 3. 3,937. All right, over here we have 7, because 0 plus 0 plus 0 plus 0 plus 0 is 7. 0 plus 0 plus 1 plus 0 plus 2 is 3. 6 plus 2 is 8, plus 1 is 9. 3 plus nothing is 3. And just like that, we are sitting with the same number on both sides. Which one was closer? Our Fredstimate or our estimate? Well, if we got 3,937, our estimate, without going to the front end digit, was only 37 off. So it looks like